This one's going to be our merge sort. And we did see videos on this. The idea I'm going through is to try to settle this very clearly in your mind. I'll spell it right, helps. Okay, on the merge sort, you cut stuff in half. Okay, so let's see, where's the line I can get to? See if that'll work out. So in this particular case, well, no, didn't like how that turned out, so never mind, take that back out. In this particular case, we would be merging the first 5 with the last 5. But a merge sort only works if the group that you're given, the 2 groups that you're given, are themselves already in order. That is not the case here, okay? So since we've been given this and it isn't the case, we would take a look then at just this group of 5, okay? Now that's what we're going to work with. So let me duplicate that. I'll try again. Delete, copy, duplicate. There it is. Okay. So we would take these and bring them down, and we'd say, okay, first thing we're going to do is sort this. How do I sort it? I have to break it in half and merge it. Okay. So this one, am I going to have 3 and 2 or 2 and 3? Doesn't really matter, whichever way you want to code it. So I'll take this group and I'll duplicate it. And now then this is what we're going to try to sort by merging. Same problem, it is not in order yet. So 2 or 3, doesn't matter, whichever way you go on this. So I'll take these 2 and I'm going to try to sort them. And I bring them on down. And I look and say, no, these still, not in order yet. So I'll break these in half. And I take this one and duplicate it and bring it down. Okay, at this point, no matter what number I am given, I can guarantee that array is in order because it's only got 1 element. Okay, now then, so once I hit that point, then I can come back up and say, okay, take this and replace it with this one. So I'm going to lose that one and replace it with this sorted. Yeah, I know it was exactly the same. So why did I do it? If I'll do it this way, I can do it with recursion. Okay. Now then that I've sorted the one on the left, I now have to go over here and sort the one on the right. So I'll duplicate it and I go through exactly the same steps. Is it in order? Why, yes, it is. Okay. Well, then let's get rid of the one that we had up here and replace it with the one that's in order. Okay, now then, I can merge these 2. And when I merge these 2, they wind up going into order. Okay, so now then, I've got these in order. I was handed this to start with. Well, I'm going to get rid of it and replace it with the one that is in order. And move it up to where it was. Okay, now I have done the left-hand side of this one. I have to do the right-hand side. So I'll take and duplicate it, hand it down, and I'll take a look and say, okay, have I got just one? Yes, I do. All right, that is in order. Great, so I'll come back up here and I'll throw away the one that I had, replace it with the one that is in order. And if you'll notice at this point, the left-hand part of the 5 is in order. So I come back up to this and say, okay, I can get rid of you now. Let me get all 3 of these. Okay, you guys I can get rid of, and I will move this up in place of it. Okay, now then that I've done that, I've done the left-hand side, it's in order, but I haven't sorted the right-hand side yet. It happens to be in order, but code-wise, I wouldn't know that. So I'll take these 2 and duplicate it. Well, if I could get that to work, I'll try that again. So I'll take these 2, duplicate, Okay, move them down. And I'll say, okay, now I have to break this in half and sort each one. So I duplicate this one, drop it down. It says, hey, it's only one. Okay, put it back up in place. Over here, I'll duplicate this one, drop it down. It says, hey, it's only one, put it back in place. I merge these two, they're in order. So I can take the originals that I had, now toss them and replace it with these two that I can guarantee are in order. But get them, yeah, got them. Okay. Now then, I still have the two pieces. These two pieces need to be merged. They can be because I know at this point, they're both halves are in order themselves. So if I start merging, I've got the 7 and the 3 to merge. Okay, so the 3 will come down here first. Okay, then that leaves me with the 10 over here. Well, I need this 7 to come down, and this is the merge process. Okay, that leaves me with 12 and 10. Bring the 10 down, and this is something we talked about last time. At this point, there's nothing left to merge on this side, so go to the left-hand side and just pull them down, and then it will be in order. Okay, now then, coming back to our original, oh, that was supposed to say, I thought I put a merge sort in that. I guess I lost it someplace. I'll put that back in. M-E-R-G-E, that could be what happened to it. Okay, so that's merged. All right, so at this point, the left-hand side has been placed into order. So I'll get rid of the originals, toss those, and bring these little guys and put them in place of it. Okay, my left-hand side has been sorted. Now I have to sort the right-hand side. Oh boy. Okay, so we pick all these, and that's the nice thing about computers. Computers never say, oh boy. Okay, they just do their job. All right, duplicate these, bring them down. I've got to split these in half. So when I split these in half, I'm going to do this side first. So I'll duplicate it. Oh, hit the wrong button again. Okay, I'll duplicate it. Bring them down. Now then I'm looking at this going, okay, I still have more than one, so I've got to split it in half and keep going. So I'll take this half, duplicate it, bring it down, and then we're going to split this in half. So that one I just dropped down. It's all by itself. It has to be in order. Put it back up. Take this one, drop it down. Has to be in order because it's all by itself. Put it back up. These two have are now merged. Yeah. Go ahead.
Question for you on this merge sort. So
Sure.
if this is doing it the same way that we wrote the last class, would it be splitting and giving you 3 on the drop down, or would it give you 2? Because if it's in integer division, it would be 2, right?
Yeah. So, and it depends on how you wish to write it.
Okay.
The way but you are correct. The way that we wrote it last time, we did do the integer division. So we'd have been doing 1 and 2 instead of 2 and 1. Correct?
Yeah, because it would drop down and be 2, and then when it would look at the next 3 that are left, 3 divided by 2, we would only handle 1 that time, and then we'd handle the last 2.
Yep. Yep. You are correct on that.
I just want to make sure. I was wondering where the 3 came in.
No, that's the kind of question you should ask on this thing. Now, one reason I wanted to step through this, and while I'm talking, I'll continue on so we can get through this. The way the pictures are drawn is kind of after the fact, and as a result of that, you get there's a misperception that this thing goes row by row by row, and it doesn't. It works left as far down as it can go, then works right, and so you get this effect that we're doing now. You don't sort that whole row and then that whole row on this. Okay, these two need to be merged, and when they are merged, we will wind up with this. Okay, now that those have been merged, they are in order, so get rid of those little things. And while we're doing this, I'll go ahead and mention that what we're looking at now is considered computer science. This is the difference between information systems and computer science. On this, we'd drop those two down, they'd be fine, bring them back and merge them. And computer science tends to be much more technical. You can express what we're doing mathematically a lot faster than the way I'm just having to say it word by word by word. Let's see, so we need to merge this half and this half, so that would be 2, 4, well, I can grab right, that helps a whole lot. And you have to decide, does this appeal to your mind? If it does, then you definitely want to go computer science. If just watching this drives you crazy, but you still kind of like code, then that means you drop into the more the information or the business side of this world. And it's a little more entertaining. Okay, we now have the right side done, so I'll go ahead and delete that.
So with the whole idea of sorting, this will of course vary language by language. Java is just nice because where it's object oriented, we can really see it at play doing the sorting algorithms, but this will be applicable across all languages, right?
That is correct. Any language,
just have to see how it's doing it, how to tell it, I want to do bubble sort in this language or write the algorithm for it.
Yes. And the same algorithm I'm showing you, if we were to do this class in Python, then we'd go into Python lists and do it with Python lists. This kind of sort has been around back in the 1970s. I used to do this exact same sort with Fortran. And that was a mathematical language. And so that's the thing about computer science. A lot of the algorithms have been established for so long. Now I'm doing the merge right now, that's what's happening. That, you know, let's show them to you. And Donald Knuth, K-N-U-T-H, wrote a series of books, not just one, but a series of books on exactly what we're doing right now. And he was a mathematician. He got really deep into the mathematics side of it. Interesting book. I have it on my bookshelves. Someday I might actually read it. Probably not, because what I do is use it for a reference, or used to, before you could just go Google everything in the world. And you'd use that as a reference to figure out how to do sorts based on what the data itself was organized like. Okay, so when it's all over with, we wind up with it sorted.